Friends, welcome to my YouTube channel. Another interesting session on machine learning. In the last video, we were discussing on exploratory data analysis, that is univariant, bivariant, and multivariant analysis. In this video, I am going to discuss about hypothesis testing and p-value. Mainly, my focus is on p-value. Let's start. This is an interesting quote from Edison. I have not failed. I have just found 10,000 ways that won't work. A very nice quote from Edison. Let's continue with p-value. So mainly I am discussing here p-value and hypothesis testing. So what is first I am giving an idea about hypothesis testing. It is introduced by Ronald Fisher, Jesse Neiman, Carl Pearson and Egan Pearson. It is Pearson's son. See, you are familiar with Pearson's correlation coefficient. We have separate video on Pearson's correlation coefficient that gives the strength of the relationship between the variables. See, all those aspects, standard deviation, mean, median, mode, all those aspects very important. You can watch the videos in the playlist statistics and feature engineering. Statistics one playlist is there, feature engineering another playlist is there. You can watch those videos. Fine. Hypothesis testing. See, a statistical hypothesis is an assumption about a population parameter. A population and sample, it is another concept in statistics. You have the videos in the playlist under statistics. Please watch those videos. This assumption may or may not be true. The main thing, a statistical hypothesis is an assumption about a population parameter. Hypothesis testing is a statistical method that is used in making statistical decisions using experimental data. Here the important thing is, in hypothesis testing we use experimental data to make statistical decisions. In machine learning we are more interested in decisions and predictions. Hypothesis testing is basically an assumption that we make about the population parameter. It's an assumption. That is hypothesis testing. Another thing is null hypothesis. It is denoted by the letter H suffix 0, H0. Null hypothesis is a statistical hypothesis that assumes that the observation is due to a chance factor, where it is just due to a chance factor. Our assumption, our statistical hypothesis is just a chance factor. That is known as the null hypothesis, denoted by H0. I will give you an example, then you will get more clarity for null hypothesis and alternative hypothesis. The alternative hypothesis shows that observations are the result of real effect. Here the observations are the result of a real effect. You need to conduct experiments. You need real-time data for alternative hypothesis. But for null hypothesis, it's just a chance factor. I will give you an example, then you will understand. Let us consider the example of tossing a coin. A null hypothesis might be that half the flips would result in heads and half in tails. The alternative hypothesis might be that the number of heads and tails would be very different. For example, this is the probability for null hypothesis. The probability is 0.5. For alternative hypothesis H1, it is not equal to 0.5. Suppose we flip the coin 50 times, resulting in 40 heads and 10 tails. Given this result, we would be inclined to reject the null hypothesis. See, we assumed that that's what really happening, but in our case, in our experiment, we have to reject the null hypothesis because we got a result of 40 heads and 10 tails. Then we would conclude based on this evidence that the coin was probably not fair and balanced. Some problem with the coin. Normally it has to come, around, some of 40 to 60 range, or 50 to 50 range, or 45 to 55, in that. Here it is 40 heads and 10 tails. It's some problem with the coin, and we have to reject the null hypothesis. From this example you understood clearly what is the null hypothesis and alternative hypothesis. Now I am getting into p-value. It's also known as probability value, p-value. A p-value is used in hypothesis testing to help you support or reject a null hypothesis. This is whether we need to support the null hypothesis or we need to reject the null hypothesis. That is based on p-value. So you got an idea of p-value. Based on the p-value, we will support or reject the null hypothesis. The p-value is the evidence against a null hypothesis. The smaller the p-value, the stronger the evidence that you should reject null hypothesis. Very important. If p-value is small, you should reject the null hypothesis. And the more important significant, your experimental results will be more important. And more important is your experimental results. If your p-value is small, p-value is less, p is small, then your you should null hypothesis, you should reject the null hypothesis, and you should depends on your experimental results. You have to stick on your experimental results. Your null hypothesis is wrong if p-value is small. If p-value is high, your null hypothesis is correct, is strong. That's what. So you got more clarity. I will give you a practical example. A p-value of 0.0254, that means it is 2.54%. This means there is a 2.54% chance your result could be random. That is very small. Here the p-value is very small. What is the meaning? If a p-value of 2.54% or 0.0254 means there is a 2.54% chance your result can be random, can be happen by chance. That is pretty tiny, and we have to reject the null hypothesis. On the other hand, a large p-value of 0.9, that means 90%, means your results have a 90% probability of being completely random and not due to anything in your experiment, and we have to depend on the null hypothesis in this case. You are getting my point? These are all very interesting concepts. See, p-value is smaller means you should reject the null hypothesis because only 2.54% chance your result could be random. When for a large p-value, that is 90%, 0.9 means your results have a 90% probability of being completely random, and you need to accept the null hypothesis and reject your experimental results. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis, and the more important is your experimental results. That's all. So from this table, it's a perfect table. This will give you complete idea. This is the p-value. This is the alternative hypothesis. This is null hypothesis. P-value small, null hypothesis is weak, and alternate hypothesis, you have to come up with the alternate hypothesis strong. P-value high, that means your alternate hypothesis is not needed, it's weak, and null hypothesis is strong. This is the table you can remember. From this you can easily understand what is p-value, null hypothesis, and alternate hypothesis. Really interesting, this table. From this you can easily, then this is the p-value and right tail test. See, when we talk about the hypothesis test, there is left tail test is there, right tail test is there, two tail test is there. See, there is separate video on the different types of hypothesis test, that is right tail test, left tail test, and two tail test in the playlist statistics. You can watch that video. Here I am considering a right tail test. See, this is the right tail test. Here you can see the graphically the p-value is the area of in the tail of a probability. This is the tail. See, this is a this is a Gaussian distribution, right? This Gaussian distribution, or we call it as the normal distribution or bell curve, all are same. This is a normal distribution or Gaussian distribution. It's a bell curve. So here, which is the this area, this is, we call it as the outliers, right? This area, the p-value is also somewhat similar concept only. We how do we come up with the outliers? See the p-value, this value, see from here, this is a right tail test. So this portion we will consider. This is the critical value. How do we, from this, we will calculate the area of this portion. Graphically, p-value is the area in the tail of a probability distribution. This area is the p-value. How do this point, this critical point, how do you get? You have different approaches. Even in the outlier detection, we have videos for that. You have the Z score. Please watch that videos. IQR score, all right? IQR score, intraquartile range, IQR score, very important. You need to learn this. You can watch the videos in the playlist feature engineering and statistics also. These videos are available. Z score, IQR score. Then another one is the box plot. These are all to find. How do you get this point, right? From this only you have to find out the area. Box plot is also known as the, another name is whisker plot, box plot or whisker plot. There is separate video for these are all we are using for the outlier detection. How we can see these portion here only your outliers are coming. So these here also you will get outliers. So that is a two-tailed test. That is a two-tailed test. If it is a two-tailed test, this area also we have to. I am talking about the right-tailed test. There is separate video for right-tailed test, left-tailed test, and two-tailed test. You can that is different types of hypothesis testing. Fine. See, this area is the p-value. It is calculated when you run hypothesis test and is the area to the right of the test statistic. This is the critical value. Critical value means it can be Z score, IQR score, or from box plot you can get it. Anything. This area is the p-value. You got it. Fine. So the conclusion I have to, this is the point you need to understand. A small p, that means less than or equal to 0.05. All right. Reject the null hypothesis. This is strong evidence and the null hypothesis is invalid. A small p means less than or equal to 0.05. 0.05 means it is 5%, right? 5%. A large p-value, that means a p is greater than or equal to 0.05, means the alternative hypothesis is weak, so you do reject the null. That's what a small p-value, reject the null hypothesis. That means if it is less than this 5%, you should reject the null hypothesis. This is strong evidence that the null hypothesis is invalid. A large p-value, that means if it is greater than 0.05, means the alternative hypothesis is weak, and so you do not reject the null hypothesis. You shouldn't reject the null hypothesis. So that's all about the p-value. Thanks for watching. Please like, share, and subscribe. Thanks a lot.